Hello everyone, welcome you all back. In this video, we are going to solve some problems on mass transfer basics. That is, basic terms in mass transfer were explained in the last lecture itself. Now we are going to solve some problems on those phenomenons, right? So the problems on concentrations. First formula you are going to use in these problems is molar concentration. That is, the molar concentration C is equal to pressure divided by universal gas constant into temperature that should be submitted in Kelvin value, right? So P divided by G into T. It can be written as rho divided by M, that is molecular weight. So the first one is molar concentration equal to pressure of the component. That is, if I want to find out Ca here, you can write pressure of component A divided by universal gas constant 8314 joule per kg mole Kelvin or 8.314 kilojoule per kg mole Kelvin into temperature that should be submitted in Kelvin, right? So it can be written as equal to rho of component A, that is mass density of component A divided by molecular weight of the component A. Similarly, Cb equal to pressure of B divided by G into T, which is equal to rho B divided by M into MB, right? So this is how you have to find out the molar concentration. Next thing is mass concentration. Mass concentration is small m dot A is equal to mass density of that particular component divided by mass density of the total mixer, right? So that is the overall density, as I already told you in the last lecture itself. Rho equal to, in case the mixer consists of component A, component B and component C, then rho equal to rho A plus rho B plus rho C. Okay. Next thing is mole fraction. Mole fraction is X suffix A equal to molar concentration of the particular component divided by molar concentration of the total mixer. So XB equal to similarly CB divided by C. And the third one, average molecular weight of the mixer, right? So in case, consider air is consisting of hydrogen, nitrogen, oxygen, all those components, right? So the major components. Now the average molecular weight of the air has to be found out using this formula, right? So next thing is Ca, that is, I already told you, no, rho equal to rho A plus rho B plus rho C. Similarly, molar concentration C equal to Ca plus Cb plus Cc, right? So third one is Pv equal to mRT. This formula you know from the thermodynamics itself. Density is equal to m divided by mass divided by volume is density, and then the gas constant R equal to universal gas constant divided by molecular weight, right? Similarly, m dot A plus m dot B equal to 1 and x dot A, xa, that is the total mass fraction is equal to 1. Similarly, the total mole fraction is equal to 1. These are all the formulas you are going to see, you are going to use while solving the problem. Now go to the problem. The first problem given is the composition of dry such standard atmospheric air is given on molar basis to be 78.1% of nitrogen, 20.9% of O2, 1.0% of argon. Now I am considering the air consists of only three components. One is nitrogen, oxygen, argon. These three components only. Now I am going to find out the mass fractions of all components. So to find out the mass fractions, initially I am going to find out average molecular weight. You know, average molecular weight is nothing but, here you have the formula, no? This formula I have to use, right? So molecular weight into percentage of the particular component. So nitrogen is having 0.781 and the molecular weight of the nitrogen is 28. Similarly, oxygen molecular weight is 32 and the percentage is this one. The molecular weight of the argon is 39.9 and it is consist of 1%. These values, molecular weight values, you can take from the hidden mass transfer data book in the last section, right? So I think after page number 175, the mass transfer will be given where the diffusion coefficient value, molecular weight values, all those values will be given in those section, right? You can refer that HMT data book to find out the molecular weight of the different components. For nitrogen it is 28, you know, for oxygen it is 32, you know, for hydrogen it is 1, you know, but for argon you have to take from the HMT data book only, right? So first thing we are going to find out mass fraction. So the mass fraction MA equal to rho A divided by rho. This can be written as like this. So how this formula came means, so you know that Ca equal to rho A divided by M, right? So from this I can write rho A equal to Ca into Ma. This formula I am substituting here. This is for component A. For the total mixer, rho equal to C into M, right? This is I am substituting here. So the mass fraction becomes Ca divided by C, Ma divided by M. Right. So now I am going to find out the mass fraction for the different components. First thing, going to find out nitrogen. For nitrogen, the mass Ca divided by C, that is Ca divided by C, molar concentration divided by total molar concentration is 0.781, and the molecular weight of the component Ma is 28. No, for and then average molecular weight of the M is, we find out now here, 29. I am substituting here. And mass fraction of nitrogen is 754, right? For oxygen it is Ca divided by C, that is mass fraction is 0.209, and then molecular weight of the oxygen is 32, average molecular weight is 29, so it comes 0.231. Similarly you find the value for argon. Now go to the second problem. Here it is given that a vessel contains of a binary mixture of O2 and N2 with partial pressures in the ratio 0.21 and 0.79 at 20 degrees Celsius. If the total pressure of the mixer is 1.1 bar, calculate the following. You have to calculate molar concentration, mass densities, mass fractions, molar fractions of each species, right? This it consists of two species, no, O2 and N2, right? For these two species you have to find out molar fractions and average molecular weight, right? So now the given data is, it is in the partial pressures of 0.21, 0.79 and the total pressure is 1.1 bar, right? So now first thing, partial pressure of O2, partial pressure of oxygen is equal to, it is in the ratio of 0.21, 0.79. In case the total pressure is 2 bar, 0.5 percentage of pressure is given by O2 and 0.5 percentage of pressure is given by N2, which means 1 bar of pressure is given by O2, 1 bar of pressure is given by N2. Similarly, here in the total pressure, the O2 gives 0.21 percentage and N2 gives 0.79 percentage, right? So here the total pressure is 1.1 bar. I am converting this bar into Newton per meter squared. So I am putting 10 to the power 5. So the total energy is 0.21 into 1.1 into 10 to the power 5. Similarly, for N2 I am taking 0.79 and the total pressure into conversion factor, right? And then the temperature given is 20 degrees Celsius, so it is 293 Kelvin. So I am going to find out all these values, right? So the first thing, molar concentration C, you know the formula, C equal to P by GT, that is pressure divided by universal gas constant into temperature, right? So now for each component I have to find out. For an oxygen, CO2 equal to partial pressure of the O2. So if this pressure is total pressure, these two are partial pressures, right? So component pressures are called as partial pressures and total pressure is called as total pressure, right? So now for C, now molar concentration of O2 is given by the formula P of O2 divided by universal gas constant into G. So P of O2 we have find out now 0.21 into 1.1 into 10 to the power 5, and then G is 8314 into temperature is 293. You can find out this value. Similarly, for molar concentration of nitrogen, put the partial pressure of nitrogen here and you can find out the value like this, right? So next thing you have to find out the mass densities. You know the formula for mass density, you know that C equal to rho divided by molecular weight. Here you have to find out the mass density. So rho equal to C into M. You know the value of C for O2 and for N2 and the molecular weight of O2 and M2. By this way you can find out mass density of O2 and the mass density of N2 like this. So you can find out overall mass density. You know that rho equal to rho A plus rho B. By this formula you can find out the overall density. Then the third subdivision, mass fractions. Mass fractions is nothing but m dot of A, right? So m dot of O2 can be found out by this formula. So this formula is rho, component of mass density of the component A divided by overall mass density. This is the formula which we have already discussed. By using this formula, here the component A is nothing but m dot O2, which is equal to rho of O2 divided by total mass density. So these two values already we have find out. Substitute that value and find out the mass fraction of O2 and the mass fraction of N2, right? So next thing, total concentration. You know that the total concentration C equal to Ca plus Cb plus how many components are there? It is nothing but Ca plus Cb plus and etc. Right? So C equal to CO2 plus Cn2. Just sum up those C concentration values and you can find out total concentration. Similarly, most mole fractions X of A, component A, is equal to C, molar concentration of component A divided by total molar concentration. Here I am going to find out mass mole concentration for O2 and N2. So XO2 equal to CO2 divided by C. These two values we have already find out. Just substitute those values and find out X02 and Xn2, right? So next thing, average molecular weight. You know the formula. In the last problem itself we have discussed how to find out the average molecular weight, right? So by that way you can find out average molecular weight. Now we will solve next problem. Okay, in the next problem, a mixture of O2 and N2 with their partial pressures ratio. Here also the partial pressure ratio is given in a container at 25 degrees Celsius. So the temperature and the partial pressure ratios are given. Calculate molar concentration, mass density, mass fraction of each species of a total pressure. The total pressure value also given, that is 1 bar. What would be the average molecular weight of the mixture? So the same problem, it is given in different words. So we can follow the same problem. So the partial pressure of P of O2, oxygen, partial pressure of oxygen is equal to 0.21 into total pressure. Similarly, partial pressure of nitrogen equal to 0.79 into 1 into 10 to the power 5, right? So next thing we are going to find out molar concentration. C equal to, you know the formula, P divided by G into T. So substitute the values and you can find out Cn2 and CO2. Similarly, molar concentration, you know that molar concentration C equal to rho divided by molecular weight. From this you can find out rho of A equal to Ca into Ma, rho B equal to Cb into Mb, and you can find out rho equal to rho A plus rho B, right? So with these formulas you can find out rho of O2, rho of N2 and total mass density, right? Next thing, mass fractions. You know the formula, M of component A is equal to mass density of the component A divided by overall mass density. By this formula, that is M dot equal to rho A divided by rho. Similarly, M dot B equal to rho B divided by rho. By this formula you can find out mass fraction of the oxygen and the mass fraction of the nitrogen, right? Next thing, you know how to find out the average molecular weight. So we can go for the next problem quickly, right? So the next problem is The molecular weights of the two components A and B of a mixer are 24 and 28, right? Here the molecular weights of the component A and component B are given, right? So the molecular weight of the gas mixer, the total molecular weight is found to be 30, right? So if the mass concentration of the mixer is 1.2 kg per meter cube, determine the following, right? So we will solve the problem. First thing, given the molecular weight, that is the component A molecular weight capital M suffix A equal to 24. Similarly for the component B, the molecular weight is 48. I'm sorry, in the problem just change it to 48. It is not 28, it is 48, right? So it is 48, and then the total average molecular weight of the mixer is 30. Then mass concentration rho of the mixer is equal to 1.2 kilogram per meter cube, and the temperature is given. You have to find out density, molar fraction, mass fraction, total pressure. These are the values you are going to find out. So first, to find out the density value of the components of the each components, now find out the molar concentration of the mixer. The molar concentration of the mixer can be find out C equal to rho divided by M. These two values are given in the problem itself, that is rho equal to 1.2, M equal to 30. By using this formula you can find out molar concentration of the mixer, right? Now you know C equal to total molar concentration of the mixer equal to molar concentration of each component. I am writing this formula like this: Ca plus Cb equal to this value 0.04. Similarly, we know that rho A, that is C equal to rho by M. By this formula, from this formula I am writing rho of A equal to Ca into M into A. For component B also I am writing the same equation. Now you know the value of Ma, molecular weight of component A, is 24. So rho A equal to 24 Ca. Similarly, molecular weight of the B component is 48, and I am writing rho B equal to 48 Cb. Okay. Now we know that rho A plus rho B equal to total density, total mass density. Rho A value is nothing but 24 Ca, rho B is 48 Cb, and I am substituting these two values here. 24 Ca plus 48 Cb equal to rho, right? Solving the equation, this is equation number 2, and equation number 1 is here, right? Ca plus Cb equal to 0.04. Right, you can solve and find out the value of Ca and Cb from these equations, right? In this equation you can write Ca equal to 0.04 minus Cb. So just substitute that value here. Ca equal to 24 into 0.04 minus Cb plus 48 Cb equal to rho, right? From this equation you can find out Cb value, right? So once you know the Cb value, automatically from this equation you can find out the Ca value. So I find out the Ca and the Cb value just like that. Okay. Next thing, density values has to be, now we are going to exactly solve the problem. First thing, we are going to find out the mass density of the each species. You know rho A equal to 24 Ca. Now you know the value of Ca and substitute that, find out the value of rho A. Similarly, rho B. Next thing, mole fractions. You know the formula for mole fraction, Xa equal to component of concentration of component A divided by total concentration, right? By this formula you can find out these values. You know the formula for mass fraction, M equal to rho of particular component divided by rho of the mixer. By this value we can find out these two values, right? In the last thing, you are asked to find out total pressure at 290 Kelvin. You know the gas law, PV equal to mRT. From this formula you can write P equal to M divided by V into RT, or P equal to rho RT. Here R you can substitute as G divided by M. This value you know. All these values you know, substitute all the values and find out the total pressure value. Okay, thank you all. In the next video we will solve the problems on steady state diffusion through a stationary medium, that is plane membrane. Okay.